In this video, we'll talk about friction forces. So what is friction? Friction is the resistance encountered when an object moves along a surface or through a medium. We have two particular kinds of friction. We have static friction, which is a friction force for a stationary object that acts in the opposite direction as the pushing or pulling force. And the equation for our static friction is symbolized by F to the subscript of S is equal to mu s times our normal force. We have kinetic friction, which is the friction force of an object in motion that acts in the opposite direction as a pulling or pushing force. And the magnitude of our kinetic friction is measured as the kinetic friction is equal to mu k times our normal force. So if we look at our first problem, our problem says, suppose a block with a mass of 2.5 kilograms is resting on a ramp. If the coefficient of static friction between the block and the ramp is 0.35, what maximum angle can the ramp make with a horizontal before the block starts to slip down? So if we summarize the information we're given, we see that the mass of our block is equal to 2.5 kilograms. Our static friction is given to us as 0.350, and we're asked to find our angle, which is what we're trying to solve for. So if we go over to our free body diagram, if we pretend this rectangle is our block, we can see the forces acting in the positive and negative y direction, as well as the positive x direction and negative x direction. So if we were to sum up our forces in the x direction, we'll see we have the force of our mass times gravity times our sine of cosine acting in the positive direction, and our force acting in the negative x direction. So we'll have minus our static friction force, which is equal to 0 since the block is stationary. And then if we sum up our forces in the y direction, we see we'll have our normal force acting in the positive y direction minus our force of mg times cosine times theta acting in the negative y direction. So we'll have our normal force minus mg times cosine our theta, which is also equal to 0. If we look at our sum of our forces in the y direction, we can get n by itself, where our normal force will be equal to mg times cosine our theta by adding mg cosine theta to both sides of our equation. So now we know that n is equal to mg times cosine of theta, and that our equation for the static friction is our coefficient for static friction times our normal force. So now we can plug in n into our equation for our static friction into our equation for the sum of our forces in the x direction. We'll see that mg times sine theta minus our coefficient of our static friction times n, which is equal to mg cosine theta, is equal to 0. So we're trying to solve for theta. So if we add our static friction force to both sides, we'll see we'll get mg times sine theta is equal to our coefficient of static friction times mg times cosine of theta. Now if we divide each side by mg of cosine by theta, we can get our coefficient of static friction by itself. So we'll see that our masses will cancel out, our coefficient for gravity will cancel out, which will be left with sine theta over cosine theta is equal to the coefficient of our static friction. And we should recognize that sine theta over cosine theta is the same as having our tangent theta equal to our coefficient of our static friction. We can solve for theta by taking the inverse of tangent times our coefficient of our static friction, which is given to us. So if we do so, theta is equal to the inverse tangent times 0.350 will give us a maximum angle of 19.3 degrees of an incline. In our next problem, it states that a flatbed truck is carrying a crate up a 10-degree hill. The The coefficient of static friction between the truck bed and the crate is 0.35. Find the maximum acceleration that the truck can obtain before the crate begins to slip backwards relative to the truck. So we have a free body diagram illustrated to us to the right. Before we start, let's summarize the information we're given. We're given that the angle of the incline is 10 degrees. Our static friction is 0.35. And we're trying to find the maximum acceleration the truck can achieve before the block starts to slip. First, we want to start with summing up our forces in the x and y direction. We'll have the truck moving up the incline as the positive x direction, and then our direction to the left will be our negative x direction. So in our negative x direction, we'll see we have mg times sine of theta. So since this is moving in the negative x direction, we'll have a negative value of mg times sine theta. And moving in the positive right direction, we have our static friction force, and this is equal to 0. And we know that force is also equal to mass times acceleration, and that static friction is also equal to our coefficient of static friction times our normal force. And so if we sum up our forces in the y direction, we'll see that we have our normal force acting in the positive direction minus mg cosine of theta acting in the negative y direction. So we'll have our normal force minus mg cosine of theta, which is equal to 0. And if we solve for our normal force, see our normal force is equal to mg times cosine of theta, which we can plug in for n, which is also our normal force, into our equation for our sum of our forces in the x direction. So if we do so, we'll have mass times our acceleration is equal to negative mg times sine of theta plus our coefficient for static friction times mg cosine theta. And since we're trying to solve for acceleration, if we divide both sides by m, we'll get a final equation for an acceleration of negative g times sine of theta plus our coefficient of static friction times g of cosine theta, since our masses ended up canceling out. Now we have all information to where we can solve for our maximum acceleration. So we have negative 9.8 times sine of theta, which is 10 degrees, plus our coefficient of our static friction of 0.350 times 9.8 times cosine of theta, which is 10 degrees. And if we multiply and add this together, we'll see that our maximum acceleration before the block begins to slip will be 1.68 meters per second squared.